Hi everyone, I hope you are doing well. My name is Behruz and I am a professional Rust developer, and today we are here to talk about unsafe Rust. In the future, we are going to discuss about more in intermediate level. We don't work with their safe Rust anymore because we want to know more about unsafe for us because it's really important. And if you want to write embedded code, or you want to call function from other language or communicate with other language like C, you need to know about unsafe Rust. All the code you have learned so far has had a Rust memory safety guarantee. However, Rust has a second language hidden inside it that doesn't enforce that memory safety guarantee anymore. It's called unsafe Rust and work just like regular Rust, but give us extra superpowers. To switch to unsafe Rust, you use the unsafe keyword and then start a new block that holds the unsafe code. As some advantage you have some advantage in unsafe code, and you can take 5 action in a unsafe Rust that you can't in a safe Rust. For example, the reference a raw pointer, call an unsafe function or method, access a memory or multiple statics variable. You can do it in a safe Rust. Implement an unsafe trait, access the fields of unions, call a function from other languages like C, or you want to write embedded functions, embedded programming, and it's really important. So in this take 5 actions is really important because you can't use them in a Rust safe Rust. Uh, but in addition, unsafe Rust not does not mean the code inside the block is necessarily dangerous, or that it will definitely have memory safety problems. The intent is that as the programmer, you must ensure the code inside the unsafe block will access memory in a valid way. Uh, it's really important, to understand raw pointer before we start use the unsafe code, because you must know about raw pointer in Rust, because is different from other language like C or C++, because they have some rules, and we must sure uh, to know them better, but then start the unsafe programming in Rust. But for demonstration, today we just want to do some examples and show you to how to use the unsafe code. Let's do it. Okay, let's create a new project, and let's name that unsafe Rust, because we want to show you some example in how to use unsafe Rust. Okay, let's do it, and let's name that unsafe Rust. We create a binary application. The easiest way to show you how to use unsafe code, work with the raw pointers. For example, we create raw pointers and dereference the raw pointer and print them. Let's what will happen. Okay, create a raw pointer. The type is going to be a mode I32, and we assign them. Let's start with assign them with the null pointer. Okay, and the null mode, we assign the a memory location with a null, and it's really dangerous if you don't check them. It's going to crash your program. Okay, and let's see. Print a pointer for us, please. Compiler, can you do it? Dereference a pointer. Okay, as you can see, we have a error here, and compiler says dereference arrow pointer require unsafe function or block. So how can we print them? So we just put them in unsafe block. It's really easy. Yeah, it's easy. And let's run it. As you can see, we have a problem here. Our program crashed somehow. So because you can dereference a raw pointer if the raw pointer is null. So you must ensure that the pointer is not null and aligned. Okay? So let's align the value or put the some value to the pointer. Okay, it's really easy. We assign the value to the pointer. After that, okay, let's run it. Hurrah! Yes, we print the 10, and it's really easy to use the unsafe code. Yeah, but you must show the pointer is not null. Okay, let's use them with the if. Use the if to check the is null. Is null or not. P is null. Okay, and we put them in the if block. And after that, if we assign them with the null, and it's not gonna crash because it's going to pass the if, and nothing happened, and it's not going to print anymore. Okay, it's really easy. See, so you must ensure the pointer is not null or aligned. Okay, it's really important. You must uh, write some documentation to the user and warn you to check the null is pointer is going to be null or not. It's really important, and somehow you must write some safety in here. So user must ensure the pointer is not null. Okay, that's we have to warn the user about this line of code. Okay, it's really important to understand them. Let's create a struct, and somehow we create a parent struct and a child struct, and we drop the parent, and what will let's see what will happen, and if you use a raw pointer and unsafe code. Okay, let's create a child and parent struct, and let us start with the lifetime without raw pointers. Okay, uh, create a struct parent, the name, and it's going to be string, and create another is child, and we want access to the parent with the lifetime. Okay, so use them the lifetime of parent, and we need to add lifetime to the child, of course. Okay, let's create and print the parent with the drop, and what will happen. Okay, this is easy. Let create parent, and parents let's name master to string. Okay, and let's create a child, and child need to have parent, of course. Okay, and going to be okay. Let's comment these few lines. Okay, and let's print the child, the name and the name. Okay, print Alan. Okay, and we need to access the parent with the child. Okay, the name. Okay, we need to remain the here and the parent. Sorry. Oh, here. Parent. What's not going to name? Why we don't have access to the name? Parent. Oh, okay. It's gonna compile here. Sorry. Okay. As you can see, the master is printed here, and if we drop the parent compiler complain about or complain, and as you can see, compiler said the parent move out of the parent occur here, so somehow is not an access to the parent. So if we use them as a raw pointer and we drop them, let's see what will happen. Okay, we change them as a const is another type of raw pointer, is a immutable raw pointer, and you can assign a value to immutable raw pointer. So let's see and cast as a const parent, and if we drop the parent, let's see the print what would be. Okay. Okay. Oh, let's remove the lifetime here. And okay. First, we need to do reference it because it's a raw point. Okay. Let's do reference the raw pointer here, and we need them to put them in an unsafe block because it's the unsafe. Okay. As you can see, it's going to print a gibberish because the drop occur here, and the compiler doesn't complain about the move. It's really dangerous. So you must sure the parent is not going to be dropped, or if the parent drop, you must drop the child and somehow warn the user here. So it's really important. So somehow it's really difficult to manage raw pointer, because if you user drop your strike and is not going to be accessed anymore, and so the memory is gone, and the somehow is going to be memory leak in the future. If it's really important because it's dangerous, your memory is going to be leaked, and your program is going to crash in the futures. So you must ensure that the drop when the drop occurred and show you some error with the assert, or I don't know. It's really important to warn the user, and it's enough for today because it's just for demonstration. In the future, we start with the raw pointers and introduce them, how to use the raw pointer, how to use a slice with the raw pointer, access the memory location, and we are gonna write some safety for them because we need to warn the user, and you're gonna familiar with the this type of programming, and you must follow some rules for the raw pointers because you need to know them better. And in the future, we are going to create a maybe we are going to create a doubly linked list with raw pointer, pure raw pointer, and we manage them, how to drop them, how to clean the memory, and we are gonna learn many more in the future. Okay, I hope you enjoy this tutorial and have a good day. or night. Bye.